Hello everyone, I'm Dr. Jyoti Thakre, Assistant Professor from Department of Chemistry. So today I will give a brief idea about the syllabus in semester 1, that is engineering chemistry. In engineering chemistry, total it is of 50 marks, out of which 40 marks is your university exam, which will be based on complete syllabus, and 10 marks is your internal, which is based on your sessional 1 and 2 performance as well as assignment submission. So total engineering chemistry is for 50 marks. The 40 marks university exam that you have to give is duration for 2 hours. Now we'll see the different units that we'll be studying in semester 1. The first unit is the water technology, which is for 12 marks. In this unit, the 8 marks is for the numerical and 4 marks is for the theory part. In option, you have 50% choices there for all the units. In option, you have 4 marks practical, numerical, or 8 marks theory. The second unit is the corrosion science. The marks for this unit is 10 marks. The third unit is the construction material, that is the cement, which is for 10 marks. And the last unit in this syllabus is green chemistry and battery technology, which is for 8 marks. So total we have a 40 marks. Now we'll see what is the syllabus for the first unit, that is water technology. The weightage for this unit is 12 marks. In this unit, we'll be studying hardness of water and different types of hardness. The next topic is the domestic water treatment, which contains brief discussion of coagulation and sterilization using ultraviolet rays, ozone, chlorine, and breakpoint chlorination. The next topic is industrial water treatment, which contains softening of water, in which we'll be studying principle, reactions, advantages, limitations, and comparison of lime soda process, zeolite process, and demineralization or ion exchange process. The next topic in this unit is boiler troubles, in which causes, effect on boiler operation, and method of prevention, carryover, priming and foaming, scale and sludge formation, caustic embrittlement, boiler corrosion, and in which we'll be studying internal conditioning, in which we'll be studying phosphate, carbonate, and calgon conditioning. In this unit, we have a numerical. The lime soda numerical is for 8 marks, whereas zeolite numerical is for 3 to 4 marks. The next topic is desalination using electrodialysis and reverse osmosis process. The last topic in this unit is wastewater treatment, in which we'll be studying introduction and importance of water treatment, whereas the brief idea about tertiary treatment methods. So in whole, this particular is the complete syllabus for the water technology. The weightage for this unit is 12 marks. Now first we'll see the introduction. The introduction, in which we'll be saying what is the importance of water. We all know that water is the most important part for our life, and it is abundantly present on our planet. About 71% of Earth's surface is covered with water, and about 97% of total water and Earth is in oceans and is directly not useful. 2.24% of water is trapped down south and the north poles of Earth as ice and glaciers. That means only 0.5% of total water is available for domestic, industrial, and agriculture use. So you can see only 0.5% of water is available to us. Therefore, water is life and water is precious. So we have to save water. Why water is so important to us? Water is of major importance to all living things, whether it's animal or human beings. About 75% of Earth's surface is covered with water. Up to 72% of human body is water, we know that. Therefore, the quality of water we drink is very important. The drinking water should be totally clean, pure, and free from any disease causing microorganisms. And that's why it should be properly treated and disinfected before using it for drinking purpose, because we know that if the water is infected and we drink that water, it leads to waterborne diseases like typhoid, jaundice, dysentery, etc. Why water is so important to us? Because large quantity of water is required for domestic, agriculture and industrial purpose. In domestic use, we require water for drinking, washing, bathing, cooking and waste disposal. Imagine a day without water. It is impossible. So water plays a very vital role in our daily life. Now water is also required for industrial purpose. In industry, it is required as a coolant and in the form of steam, hydroelectric power stations, steam plants, dyeing industry, sugar, textile, paper industry, whereas for chemical, pharmaceutical and ice manufacturing industry also. So we can see the water is used for domestic, industrial and agriculture purpose. The water consumption, we can see the standard norms for domestic water usage in India is 135 liters per capita per day, prescribed by the Central Public Health Environmental Engineering Organization. So water plays a very vital part in our life. So we should save water. Now we'll see what are the different sources of water. The different sources of water are surface water, underground water, rainwater and seawater. Surface water contains river, lakes, reservoirs, etc., whereas underground water is wells and spring. Now we'll see the surface water. Surface water directly cannot be used for human consumption because it contains suspended microbes, suspended particles and microorganisms which may cause different diseases in human beings. And surface water examples are rainwater, lake reservoirs, etc. So you can see here the surface water, different sources of surface water. The next is the groundwater. Groundwater is comparatively clean and clear, but it contains more amount of dissolved salt because the salts which are present in the soil, and when water travels from surface to the ground, it dissolves all the salts which are present in the soil. Therefore, comparatively, this underground water contains more percentage of dissolved salts compared to surface water. The next source of water is the seawater. Seawater, it is the most impure form of natural water. Seawater contains about 3.5% of dissolved salt, out of which 2.6% is only NaCl. Therefore, this seawater is very, very salty in nature and it cannot be used for any purpose directly. Now we'll see the different impurities which are present in the natural water. The impurities which are present in the natural water are suspended impurities, dissolved impurities, colloidal impurities and biological impurities. Now we'll see these impurities, we'll study these impurities one by one. The first is the suspended impurities. These impurities are dispersion of solid particles. Size of particle is greater than 10 raised to minus 4 centimeter. So what is suspended impurity? It is simply the dispersion of solid particle in the water. The example of these suspended impurities are waste product, clay, sand, vegetable and animal matter, etc. And these suspended impurities, they are removed by sedimentation or by filtration. Here you can see the different impurities, their size. Suspended impurities are size from minus 4 centimeter, greater than minus 4 centimeter. So there are colloidal as well as dissolved impurities scale also. Now the next impurity is the dissolved impurities. Dissolved impurities are dissolved inorganic impurities which are dissolved salts and dissolved gases. Dissolved salts which are minerals like calcium and magnesium salts, sodium, metals and oxides. The different salts which are present in the water are carbonates, bicarbonates, chloride, sulfates of calcium and magnesium. Dissolved gases which are present in the water are carbon dioxide, H2S as well as different and oxygen also. So these are the different gases which are present in the water, and these are the different salts which are present in the water. So the underground water contains more percentage of these salts because it dissolves all the salts. The water dissolves all the salts which are present in the soil. So next we'll see what are the next impurity is the colloidal impurity. The size of colloidal particle is 10 raised to minus 3 to 10 raised to minus 7 centimeter. That is finely divided clay, silica, hydroxides of iron and aluminium, and waste product. These particles can be removed by coagulation followed by sedimentation. And the last impurity is biological impurity. These impurities includes bacteria of pathogenic. Pathogenic means disease causing microorganisms, algae, fungi, aquatic vegetable matter, etc. They are removed by filtration. They can be removed by filtration, and then sterilization is done to destroy the microorganisms. Next we'll study the hardness of water. Property of water due to which it does not form lather with or foam easily with soap, or we can also in simple ways define it as soap consuming capacity of water. Now the water which is hard contains more amount of salts dissolved in it will require more soap to give the lather. So the water which forms lather with soap easily on shaking and persists for at least 2 minutes is soft water, whereas water which does not form lather with soap easily but first form a sticky curd-like precipitate is hard water. That means the soft water consumes less soap, whereas the hard water contains more soap to give the lather. So this soft water has a very good cleansing property compared to hard water, because hard water contains calcium, magnesium, salts, and which forms a sticky precipitate with the soap. And after this, dissolved salts are removed as white precipitate, and when we use the soap or detergent powder, then it gives the lather. That means this hard water requires more soap to give the cleansing property. There are different types of hardnesses. So first we'll see the types of water. There are two types of water, soft water and hard water. The soft, we can see from this reaction there, sodium soap reacts with calcium and magnesium chloride, calcium and magnesium salts of chloride, sulfates and nitrates to form a white precipitate. And this white precipitate can be removed by filtration, and when we add more soap, it gives a lather. That means simply by adding soap, we can remove this calcium and magnesium sulfate, but it forms the white precipitate. Now there are different types of hardnesses. The two types of hardnesses are temporary hardness and permanent hardness. Temporary hardness, from the name itself we can see it's temporary. That means it can be removed easily. The easy way of removing the temporary hardness is the boiling. When we boil the water, and the calcium and magnesium bicarbonates which are present easily forms the precipitate of calcium carbonate and magnesium carbonate respectively. So that means from this reaction you can see that when the water contains calcium and magnesium bicarbonate and when it is boiled, this calcium and magnesium bicarbonate, that is dissolved salts, get converted to calcium carbonate and magnesium carbonate precipitate, and this can be removed by filtration. That means by simply boiling, which we can remove these two dissolved salt, that is calcium bicarbonate and magnesium bicarbonate. Therefore they are called as the temporary hardness causing salt. So which two salts are responsible for temporary hardness? They are calcium bicarbonate and magnesium bicarbonate. Why they are temporary hardness? Because they can be simply removed by boiling. Now next type of hardness is the permanent hardness, which cannot be removed by boiling, because by boiling we remove the calcium bicarbonate and magnesium bicarbonate. But there are other salts which are present in the water are chloride, sulfate and nitrates of calcium and magnesium, as well as ferrous, ferric and aluminium. So this temporary hardness is removed by boiling. So permanent hardness needs the special treatment like zeolite process, lime soda process or ion exchange process. So these are the three processes by which we can remove temporary as well as permanent hardness from the water. So we'll summarize that temporary hardness causing salts are which? They are calcium bicarbonate and magnesium bicarbonate. Calcium bicarbonate and magnesium bicarbonate. Why they are temporary hardness causing salts? Because they can be removed by boiling. Whereas chloride, sulfates and nitrates of calcium and magnesium are the permanent hardness causing salts. They cannot be removed by boiling. They require the special chemical treatment like lime soda process, zeolite process and ion exchange process. Now we'll see what are the different units of hardness. Well, we'll see only the two simple units of hardness. So hardness is expressed in terms of ppm or milligram per liter. Now first we'll see what is ppm. ppm is parts per million, which means that it is the number of parts of CaCO3 present in 10⁶. This is what? 10⁶ parts of water. Now we'll see how it is. Why hardness is calculated in terms of CaCO3 equivalent? Because all the hardness is calculated in terms of CaCO3 equivalent. Why CaCO3 only? Because CaCO3 is the most insoluble salt and its molecular weight is 100. Why all the hardness is calculated in terms of CaCO3 equivalent? Because CaCO3 is the most insoluble salt and its molecular weight is 100. Now equivalent means what? When you calculate the molecular weight of this calcium bicarbonate is 162. So what we can say that 162 parts of calcium bicarbonates will require the same amount of soap as 100 parts of CaCO3. That means 162 parts of calcium bicarbonate is equivalent to 100 parts of CaCO3. Consider the molecular weight of magnesium bicarbonates. It is 146. So how we will say that 146 parts of magnesium bicarbonate is same as 100 parts of CaCO3. How? Because 146 parts of magnesium bicarbonate will require the same amount of soap as 100 parts of CaCO3. So we can say that whatever the amount salt, whether it's magnesium bicarbonate, calcium bicarbonate, magnesium chloride, calcium chloride. So that particular parts of that salt will molecular weight of that particular salt will require is same as the 100 parts of CaCO3 because that particular molecular weight of that salt requires the same amount of soap as 100 parts of CaCO3. Suppose 162 parts of calcium bicarbonate requires one soap. So 100 parts also require 100 parts of CaCO3 also requires one soap. That means these two parts are equal. Whatever the molecular weight of the salt, we'll consider CaCl2, that is calcium chloride. Its molecular weight is 111. So what we can say, 111 parts of calcium chloride is equivalent to 100 parts of CaCO3, which means that 111 parts of calcium chloride requires the same amount of soap as 100 parts of CaCO3. So in formula how we will put CaCO3 equivalent of any salt is equivalent to weight of salt present in the sample. That means, for example, if I say my water sample contains 100 milligram per liter of or 100 ppm of CaCl2. So it will be 100 into equivalent weight of CaCO3 is how much? 100 divided by molecular weight of that salt. So suppose my water contains 100 ppm of CaCl2, that means 100 into 100 divided by molecular weight of that particular salt which is 111. Suppose my water sample contains 50 milligram per liter of CaSO4. So what is this? This will be the weight of that salt, 50 into 100 divided by molecular weight of that particular salt. So simply this is the multiplication factor. So before using the value, we have to convert all the hardness in terms of CaCO3 equivalent. So in that, what we have to do? Simply into 100 divided by molecular weight of that salt. So whatever the weight of salt present in the water into 100 divided by molecular weight will simply give you the CaCO3 equivalent of that particular salt. So in short, what is parts per million? It is the number of parts of CaCO3 present in 10 raised to 6 parts of water. The other unit of hardness is milligram per liter. It is the number of milligram of CaCO3 present in 10 raised to 3 parts of water. So what is the relation between ppm and milligram per liter? It is simply 1 ppm is equivalent to 1 milligram of water. That means these both are same thing. So we can express the hardness of water in ppm or in milligram per liter. So these are the two simple units of water. There are other units also like degree Clark and degree French, but they are not commonly used. Okay, so these are the two common units of water. So in today's lecture, what we have studied? We have studied why water is important for living being, for industry, and where it is used. So before using the water for drinking purpose, it has to be sterilized. Before using the water for industrial purpose, it has to be treated. So we have seen what are the different sources of water. We have also seen what are the different impurities present in the water, what is hardness of the water, and what are the different units of water. So in short, we'll summarize what we have studied today. So there are different sources of water: surface water and groundwater. The impurities that are present in the water is the dissolved impurity, suspended impurity, colloidal impurity, and biological impurities. And what is hardness? We have seen the simple definition of hardness is soap consuming capacity of water. And the different units of hardness are ppm and milligram per liter. So next time we'll continue further. Thank you.